Hey everyone, and welcome to a new video on this channel. And I've been busy the past few weeks creating an Azure IoT course that I will be delivering to students starting somewhere around the end of September this year. And like most of these kind of courses, there's a project to be done near the end of the course. And that project will, of course, need to take several of the components that they studied and put them together in a meaningful way. Those kind of projects typically are not fully featured solutions, but they are used to illustrate what you have learned in that course. And of course, we deal here with the basics of working with these components. So this video is mainly meant for students to take a look at and to have some kind of a little bit of inspiration on how to get started, because the actual assignment will involve some more components or some more complexity. So what we're going to do here is basically have an event producer, let's say a device or a simulated device, sending a JSON payload to IoT Hub. IoT Hub will forward these messages to a processing component, which in this case is Azure Stream Analytics. That one is saving the data in Cosmos DB. Through the Cosmos DB change feed, we pick up the changes, we forward them to a Signalr Hub, and that means that we can create a real-time client that displays the messages as they come in into Signalr over WebSockets. So that's basically the example. Let's see how this works from a practical point of view. And let's just take a look at the client code first. So, and by the way, I will have some links in the video description that contain links to GitHub that contains this code as well. This is just basic client code written in Python using the IoT Hub Python SDK version 2. Not going to deal with the specifics. As you can see, we are just sending some temperature values. We also send the time as well from our device. So the JSON body is basically this. We send the time, we send the temperature. For demo purposes, we might add, depending on the temperature, which is also hard-coded, which again, it's a sample. Sometimes we add a custom property called alert, where we specify too hot as a value, which is very appropriate during this weather here now in Belgium at this point in time, which has been like over 30 degrees, close to 35 for several days already, which is unusual to say the least. Great. We also format our message accordingly, UTF-8 and also application JSON as the content type, and then we send the message, and we do that every 1 second. So nothing special there. Now, these messages, they are sent to IoT Hub. To send a message to IoT Hub, you have to be known as a device, as we'll see in a moment. And yeah, luckily, we can use Visual Studio Code for this, because as you can see here, there is an option, and let's see where we find that. Yeah, here it is. There's an option to look at your IoT hubs. I'm connected to this one now. And the device I'm using to connect with this code is this one here, my device. My device, I can here, again, for demo purposes, right? I can copy the device connection string, and I can then use that. In this case, the device connection string is saved in config.py. Now we also import config, and we use the connection string value or variable within config to basically create our connection information to IoT Hub from that connection string. Again, this is what you do in a test environment when you're developing and you want to see how things work, right? Good. So now we go to IoT Hub. I'm going to be quite quick in that. IoT Hub is just a service you deploy on Azure. So you create an IoT Hub. In this case, the IoT Hub is the standard tier S1. I could have used a free one for this. And actually in the course, we will use a free IoT Hub. You can create one free IoT Hub per subscription in Azure. but it's limited to 8,000 messages, where in this case we can send 400,000 messages. Now, I have been sending messages throughout the day already, so already exceed my free IoT Hub. Were it a free IoT Hub, of course. Now, in this case, what we're doing is we're doing some custom routing as well. Why do we do custom routing? Well, first of all, the course also talks about that, so we also configure that here. We have a route to storage and a route to the default endpoint. Normally, by default, IoT Hub only sends your messages to this default endpoint, which actually is an event hub. Yeah? In this case, what you see is there are two routes. There's a route to a storage account, and we just save all the raw data in Azure Storage, and then we send the data to the built-in Event Hub endpoint as well. Yeah? Built-in endpoint is here. So you can have connection information and so on, and configuration of that endpoint from this part of the UI here. Good. I'm not going to go into more details about this Event Hub configuration and how you connect to it over here. What's important to note is that in message routing configuration, there's a way to do enrichment of messages. As you have seen, in our device code, we're only sending the time and the temperature. What I also want to do is I want to send building information. What building is the device? I want to also send that with the message to our processing components further on in the data stream. I can do this by reading properties from what we call the device twin. And now we get to an important component here. The device that I'm connecting at needs to be known by IoT Hub. So in this case, there's a My Device, as you have seen in VS Code as well, a My Device device, and also the device twin has been configured. The device twin is basically nothing more than device state, which is saved as JSON by the backend. And in this case, I added a custom tag called building with the not very inventive name of big building or value of big building. So what we're basically doing in the message enrichment here in the message routing configuration is this: when we are sending, or before we are sending the message to the built-in endpoint events, in this case, we need to reach out into the twin, get the building from the tags, and then create that as a field, which will be a custom property, by the way. It will not be in the JSON payload like time and temperature. It will be a custom property added to the telemetry. Good. Now we know that we need to send this data forward from IoT Hub, from that queue, this default endpoint, this event endpoint, to a processing engine. That processing engine can be, because there are other options as well, can be stream analytics. So in the course we detail this further, but in this case, to stay with basics, what we tell our stream analytics job is basically there's an input, which is IoT Hub, and actually in more detail we are reading from that endpoint, that event hub endpoint here. You read that data, you process that data with a query, and within the query you specify what you send to the output. In this case, the output is Cosmos DB. So we're getting JSON in, we're doing some processing, and we're sending some JSON out to Cosmos DB. We're using the SQL API, and we're storing JSON documents in Cosmos DB. Now, of course, the query is where it's set. So in this case, if I click on the query, you'll see a query which is, well, it's not a basic query, but it's also not a complex query. They can be much more complex to reason about, especially when you're doing joins on time and so on. It can be quite complicated at times, but in this case, this is still a fairly basic query. And what we're doing here is the following. We're actually saying we're going to read data from our IoT Hub input, right? What data are we going to read? Well, the time and the temperature is part of the JSON message that the device is sending. So we can just refer to that. There's no issue there. Now, the building is a custom property. A custom property, you cannot just refer to it as building. You have to use a function, which is the get metadata property value function. Specify the input, which is IoT Hub. Specify the field you're interested in. Notice that I also have another field, possibly, which is the alert field, but in this case, this is the field building from the message enrichment. You have also noticed, or if you look at the code of the device is not sending the device name. But of course, the device name is known by IoT Hub, so there's a way in Stream Analytics to retrieve that device name. Again, here you refer to the input, which is IoT Hub, and because this is an IoT Hub originating message, you have to use IoT Hub with this casing, then connection device ID as device, and of course you choose device yourself. So that basically means we have 4 fields: time, building, device, and temperature. Now, of course, Stream Analytics is a temporal system, so the time is important. If you don't specify what the timestamp is, the enqueued time is going to be used. That can be sufficient at times, but normally you would want the timestamp that is sent by the device. And that's why in our Python code, we also send that time in UTC format. And automatically, when you send the time as a UTC formatted string, or a string that follows a specific format, then Stream Analytics can interpret that or convert that to a time type. So we set the timestamp to the time field here. Now this has a certain output, and then we select from that output. So we select from queue, as you can see here. We select from queue device, the building, and then the average temperature as temperature. And we also use system.timestamp here to retrieve the timestamp as seen by this query. And because we're using windowing, and windowing in this case, we're using tumbling window, which means every 10 seconds, calculate me the average of the temperature. We will have this time as the end of the window. And the windows really are fixed in this case because it's tumbling window. So we'll start at 0, then at second 10, or we end at 10, we end at 20, we end at 30, and so forth. You'll see that later when we look at the data in Cosmos DB, right? Now, when you use something like average or max or min and so forth, you'll need to group by, and that's required. We group by building, device, and then the tumbling window. Again, it's a temporal system. And in this case, we're using the windowing features, or one of the several types of windows that exist in Stream Analytics, to do one of the simplest ones, just calculating an average on some kind of fixed window in time. So great. This job is actually running. So when we are sending data, and we are sending data at this point in time, you can see that here, these messages end up within Stream Analytics, and he's calculating these averages, eventually outputting this to our Cosmos output. So let's check our Cosmos output. I won't go into details about how this Cosmos DB works, but basically you'll need an account with a database. You'll need a collection. We created a collection called IoT, and of course the output configuration in Stream Analytics has this collection configured. So it uses the IoT collection, and the output is saving them as JSON documents. You'll see that here. Let's just filter them to see the latest ones, because otherwise the order is in reverse. I click on this. This is our latest averaged value, and you see clearly here device, big building, the window end time, which ends at 10 seconds, and probably you'll see here this one was ending at 0, this one at 50, and so on. And that's our window end time. You've seen that in the query how we do that. So this is now ending up in Cosmos DB, and I'd like to send these values to a real-time client application, and we can use Signalr for that, which makes it easier to build these kind of real-time applications that use WebSockets to deliver real-time updates to a browser or a mobile device. Now, how can you do this? There are several ways to do it, but how can you do this from Cosmos DB? Well, you can configure what we call Azure function, an Azure function that is going to look at what we call the change feed. So basically, whenever changes occur in this collection, The change feed will basically tell us, okay, there's a change, let's do something with that change. What are the changes? And let's do something with these changes. Yeah. How we do that? Well, the easiest way to do that, because there are several ways to do it, one of the easier ways to do that and working with this change feed is by using an Azure function. If you go here and you say add Azure function and you select a container and so on, plus also the language that you use, and you have a function app already created. I did that, so I created a function app first called Geba Cosmos with no functions in it, and then I told Cosmos DB, create me an Azure function that I can then use to process the change feed messages. So I did that, and that means that if we go to Azure Functions, this is a function app, so Geba Cosmos is a function app. Within that function, Cosmos DB created for me a function called IoT Trigger. When I click on IoT Trigger, you will see that the input, or you will see the inputs and outputs for this function. Typically, an Azure function is triggered by something. In this case, the trigger is data, new data coming from the change feed in Cosmos DB. So the trigger is Cosmos DB input. Then we write our function and we send output, our new changes, the changes. We send this to Signalr as new messages that our client app can process. Great. Let's take a look at the Cosmos DB input. When I click on that, we clearly say, we call it input, this input here, right? This is our Cosmos DB account connection string, the actual database, the collection name we're interested in, and then, yeah, for this change feed, it uses a leases container as well. That's something that is required for this change feed processing. That's great. Then we have our function which is doing something, but it has to send the output to a, in this case, Signalr output. If I click on Signalr, you'll see the binding type is of type Signalr. We call this binding temp, not a very good name. The hub name in Signalr, basically a place where your messages are going to end up. I called it IoT to be very confusing with the real IoT Hub, right? And then, of course, you need to have a Signalr service connection string as well, which is saved as a variable in our application settings. So, of course, we need to have some code to connect this trigger, what we get as an input, to our output. And the code that was created is this code here. Not created by Cosmos DB, by the way. That's some code I, of course, had to add myself. Very basic code, no error checking, nothing. Just basic code to focus on the important stuff here, which is the input is the data coming from Cosmos DB. We process, because it's an array, we process each message in the array. Then we build a Signalr message with the time, device, building, and temperature. And of course, event dot, this here, these names are the names used by our Stream Analytics output, which is sent to Cosmos DB, right? Then when we have such a Signalr message for each event in the input, we're going to send that message to the output. We get the output with context.bindings.temp, because that's the Signalr output name, which is temp. Target, which is specific for Signalr. I used new message, could be anything here. And then the arguments is the actual message that you're sending in this case. So this function just means that whenever there's a change in Cosmos DB, you will see these changes, and for every change, send a message with a change to the Signalr hub that's in the cloud, right? Yeah, that's great. But then we need an application that is visualizing this in the browser and using the Signalr client libraries to connect to the Signalr hub in the cloud and of course get the messages, right? So if you look at Signalr here, we see we have a Signalr instance. The Signalr instance is a free one. I can use the free one for dev test only purposes. An important thing I have to note here, that of course you're going to connect, in my case, I'm going to connect from a browser client application which is running on localhost. I had to, you can add this here to the course settings, but by default there's an asterisk here in this, so it allows everything. You can of course be more strict and put your client address in there. For the rest, there's nothing really that much I need to do here. By the way, an important thing that I should note as well is that for your function app, you should also configure course. In this case, you will really need to add it or also use asterisks because it's not asterisk by default. And in my case, I added HTTP 127 and so on, 5500, because that's where my client application will live. And you also will need to turn on enable access control allow credentials here to make it work properly. Now that's great. Let's go to the actual application. The application is here, which is just an index HTML. It's using JavaScript and HTML within one page here. It's also using Vue to make it a little bit easier for me at least to create this application. Now I'm not going to go in specific details here, but what we'll do is the following thing. We are connecting to Signalr using the Signalr JavaScript libraries. We are specifying when a message of type new message comes in, execute this function, the new message function, and it gets passed the message. What we then do is we append this message to an array that we defined earlier, which is the messages array. That's basically what it does. And of course, with some magic of Vue.js, what we're doing here is we're using a v4 to populate our UI with the message here and device, the building, and the temperature. It's as simple as that. But of course, what we need to do is we need to properly connect to Signalr and also know what hub we have to watch, so to speak, for new messages coming in. And that's what this hub connection builder is doing, because we're specifying a URL here. The URL is an API base URL apparently, and then /API. The API base URL is defined here, which is window.api base URL. And then here you'll see it's this one. And that's exactly the name of our function app. That means it's connecting to the function app to actually get the connection information. And if you've looked closely at our function app, you'll probably see that we have this here in the functions. So there's a specific type of function that you can create, and that function is called here the negotiate function. If you click on the negotiate function, and by the way, it's a template that's available on the IoT Hub, on the Azure function level. So you don't have to do anything specific, just use that template. What you'll see is that from the integration perspective, you'll see that the actual input, and let's give it some time here to refresh. The actual input is HTTP, because it's an HTTP triggered function. So there you have it. And the output is also an HTTP response. And basically, that's what our client is doing. So the actual function, what does it do? It does nothing more than give the Signalr connection information as it's expected by the client app to the client app. So we just respond to the HTTP call from the client. We just respond by setting our response body to connection info. And connection info is, of course, what was configured here. If you go back to the integration part, you see that there's also an input for Signalr connection info. And indeed, Signalr connection info, the connection info parameter name is connection info, and that needs to match what we see there in that function. So that makes it work. And you'll see here that indeed our web app, which is running on localhost, the first thing it will do it will connect, or it will use the Signalr JavaScript libraries to build that connection, and it does the connection to the Azure function connection info or negotiate function to retrieve that connection information. And then after that is done, it will just listen for new messages as they appear in the hub called IoT at the Signalr level. And of course, as we have seen, we push messages from here, from Cosmos DB, into that Signalr hub. So that's basically the whole idea of creating this sample application that goes from an IoT Hub device to Signalr output to some client application that visualizes the data. I hope you found it useful. Do check the links in the video description, which contains links to GitHub, to find some of the code that was used here. And see you some other time for a new video. Bye bye.